the greatest mathematician and scientist of at this moment, Albert Einstein, because he so both were established by him. Firstly, he established or discovered the theory of special relativity during 1905
Shoot!
and
Oh!
was followed by the general relativity 10 years after the special relativity. So now the question is, alam niyo yung mean, alam niyo yung mean na ano, like Hammer was invented during 1900s and then okay, people in 1990s. Well, dito, before the theory of relativity was established, Isaac Newton's classical mechanics described spacetime as absolute and universal. Since, uh, hindi pa nga, hindi pa nga na-develop or discover yung special theory of relativity, yung sinusunod na nila that time during the 20th century or the late 19th century was Isaac Newton's uh, classical mechanics. So ano ba define classical mechanics? Yung mga kinematics, all that stuff, right? Basically, and alam naman natin yun na we discussed it during the second quarter, which was the gravitational force, the Kepler's law, the planet, stuff like that, right? So one prime example of this is the gravitational force of gravity itself, right? Since sabi niya na gravity was constant, time was also constant because it is in space, and it was absolute, and it was universal for all of us. But eventually, the theory of relativity was established and discovered by Albert Einstein, which was later on used by the modern society because it was accepted, it was proven in many experiments. So we'll get onto that later. So we can revert to the topic, to the lesson. For now, let's identify what are the two types of relativity. So the first type of relativity is the theory of special relativity. So firstly, it describes what falls under the theory of special relativity. So Now here's having theory of special relativity. Time slows down at high speeds, or this is also known as time dilation. Objects shrink in the direction of motion. This is also called length contraction. Third is events are not simultaneous for all observers. Sabihin, and yeah, it's because it's not simultaneous. It means that the time is different. That is time is time that is being experienced by two observers may not be simultaneous at all. Next is mass and energy are interchangeable. This is derived by the energy formula by Albert Einstein, most famous easy to mc squared. And lastly, nothing can go faster than so,
Speed of light,
yes, because light is
fastest thing.
the universal speed limit of the universe.
About the multiverse.
The hell? There's no multiverse. No one knows if there is a multiverse. No one has even calculated the multiverse.
So you mean
I
you're
want to be a
dumb?
scientist, and I want to discover the multiverse. And if I am going to be able to, I would probably win the Nobel Prize, and I would probably mean $1,100,000. I'll be the richest man on earth.
Technically, it won't be because somewhat the person who gave you the money is still richer than you.
Yeah. But I'll be the smartest guy
About Albert Einstein.
on Earth that is alive. But actually, if I was able to to discover the multiverse, that would be the groundbreaking thing ever.
And you're just gonna show it off to me.
Malika. Yep, and we will travel the multiverse. You want that? You want that?
Yeah. Well, let's see here. What's your age?
Right now?
Yep.
17.
So you would be dead by then.
Why?
Because you told me that the lightest the mm, that the fastest thing we have in the universe is the speed of light.
Yeah?
And while we're still going to the galaxy, we have known that if you're traveling at the speed of light, it would take about six galaxies, um, thousands of years. But we're not even allowed to go to that limit because it is the fastest thing, and no one can do that except for light. So technically, you would be dead before you reach the galaxy, even.
Well. What do
I think that should be some good work. We're at dirt now. And we get over half 64. Go farther. Found it.
Along space, it merges to a four-dimensional So, we as humans, we cannot comprehend four-dimensional things, right? But if you would make it a visual representation, basically three-dimensional space, and what flows in it is the time, making it go four-dimensional. And it says that gravity warps that space-time because it has a mass, because it has gravitational force, right? Oh, what you call this? So the gravitational field. Yeah, the grass. Space-time continuum. This is Star Talk, and I can't do that without Judd. Yeah, with me on this. Yeah. That's fun. So much fun. And I got a segment here. It's called the Space-Time Continuum. All right, I'm cool with that. You've heard that? You're kidding me? It's only the premise of every freaking sci-fi thing ever. Yes. That's time travel. I just want to ground it in a few ways that I don't think people spend time doing. So let's take this. Are you gonna ruin space time the way you do Pluto? Is that what's gonna happen right now? Nothing I can do can help Pluto. Just so you know, it's out of my hands. So here we go. 1905. You should know immediately. One thing you should know in your head. 1905. Einstein comes out with his special theory of relativity. Okay. So it's not what he called it. It was the paper that delivered it to us is called On the Electrodynamics of Moving Bodies. And no one wanted to recite that, so it's just called special relativity. But that's what it is. Because it's all about the relativity of motion and time. Okay? So, what it did was codify the fact that spatial dimensions need the three spatial dimensions, height, width, and depth, need a fourth dimension to localize it in any spatial system you're talking about. And since you need a time, then it's a space-time system. So It sounds like it's weird. Like, what are you doing, Einstein? Leave me alone with my height, width, and depth. But it turns out we have always thought about life in four dimensions. Always. And here's an example of why. If I say to you, Chuck, I'll meet you tomorrow morning at 10 o'clock. I'll say, wait, what are we doing? I'm so excited to find out. Okay. God, I love when you surprise me like this. Well, okay, I can do that, but I'll say, all right, so that's fine. I'll meet you at the corner of 5th Avenue and 34th Street. Okay? What's your next question to me? And when? Because I don't want to stay there all day waiting for you. So you knew that giving you those coordinates, right? Earth's surface, 33rd Street, 5th Avenue, 34th Street. You knew that's insufficient for us to actually meet. Absolutely. You're going to say, when? Bada bing! The time coordinate just got slapped on there. Did you just bada bing space-time? Tell him. What up, man?